You know, we're always told that evolution is all about competition, this brutal survival of the fittest world. But what if that's only half the story? Today, we're diving into the work of mathematician Martin Nowak, who makes this incredible case that cooperation is the true master architect of life. At its heart, this isn't just some abstract story about biology or math. No, it's a story about us, and about the surprising, almost magical power we unlock when we choose to help each other succeed. I mean, just think about the simplest parts of your day, like your morning coffee. That simple pleasure, it's a quiet miracle of global cooperation. The beans probably came from farmers in Colombia, the sugar from Brazil, maybe the butter for your pastry is from France, the flour from Canada, all of it heated up in an oven made in a factory in China. This huge invisible network just works together so you can start your day. But this brings up a massive question, right? We're all taught that evolution is this ruthless competition. So in a world where everyone is supposedly just out for themselves, why would anyone ever stop to help a competitor? It seems to fly in the face of the very logic of nature. And this right here is what's known as the cooperation paradox. It's this tension between our drive to compete and our instinct to work together that scientists have been puzzling over for decades. Okay, so how do we even begin to tackle this paradox? Well, for a long time now, scientists have used this really powerful thought experiment to try and unlock the mystery. It's a simple game you might have heard of. It's called the prisoner's dilemma. So imagine this. You and a partner are in separate rooms. You can't talk to each other. You each have a choice. You can either cooperate with the other person, or you can betray them. Now here's the catch. What seems like the absolute best move for you as an individual might actually lead to a way worse outcome for both of you combined. All right, let's just walk through the classic scenario. You and a partner get arrested. If you both cooperate with each other by staying silent, you each get a pretty light sentence, let's say 2 years. But if you betray your partner while they stay silent, you get off super easy, just 1 year, while they get slammed with 4. And if you both betray each other, well, then you both end up with 3 years. And this is where the cold, hard logic kicks in. Just think about it from your perspective. If your partner stays silent, your best move is to betray them, right? 1 year in jail is better than 2. And what if your partner betrays you? Well, your best move is still to betray them, because 3 years is better than 4. So no matter what the other person does, pure logic pushes you to betray. That's the dilemma. But here's where it gets really brilliant. That logic of betrayal, it works perfectly for a one-time game. But what happens in the real world, where our interactions are almost never one-offs? What if you have to see that person again tomorrow, and the next day, and the day after that? All of a sudden, the math completely changes. And that leads us to the very first key that unlocks the cooperation paradox, something called direct reciprocity. You probably know it by a different name. I'll scratch your back if you scratch mine. It's this simple but incredibly powerful idea that the shadow of the future, just knowing we're going to interact again, changes how we behave right now. And look, this isn't just some abstract human idea. It is a fundamental strategy that's woven into the very fabric of the natural world. Vampire bats will literally share blood meals with neighbors who didn't get to feed, expecting that favor will be returned one day. Tiny cleaner fish will swim right into the mouths of giant predators to eat parasites, trusting they won't become lunch. Reciprocity is a time-tested survival strategy. So back in the late 1970s, a political scientist named Robert Axelrod ran this famous computer tournament. He invited experts from all over the world to submit strategies for playing the prisoner's dilemma over and over again. And the winner? It wasn't some crazy, complex, cunning program. Nope, it was the absolute simplest one submitted, a strategy called tit for tat. So what makes tit for tat so genius? It's just how simple it is. It follows 3 basic rules. Number 1, it's nice. It always starts by cooperating. Number 2, it's provocable. If you betray it, it immediately betrays you right back on the very next turn. But third, and this part is crucial, it's forgiving. The second you go back to cooperating, it forgives you instantly and starts cooperating again. But here's the thing. Tit for tat has one big, fatal flaw. In the real world, mistakes happen, right? So what if you accidentally betray your partner? A strict tit for tat player is going to immediately retaliate. Then you'll retaliate against their retaliation. And just like that, you're both locked in this endless, destructive revenge spiral, all because of one little mistake. This is where Martin Nowak's work gets really fascinating. He ran these evolutionary simulations and found that a slightly tweaked strategy always emerged to beat tit for tat. And it's a strategy that understands the incredible strategic power of forgiveness. So this winning strategy is an evolved version called generous tit for tat. Like the original, it always repays cooperation with more cooperation. But here's the brilliant tweak. When it gets betrayed, it will occasionally forgive that betrayal and just cooperate anyway. In a messy world full of misunderstandings, this ability to break a revenge spiral is a massive advantage. It's taking a strategic gamble on mercy to get back to a relationship that benefits everyone. And to be super clear here, this isn't about being a pushover. This isn't blind altruism. This calculated forgiveness is a purely strategic move. It's the simple realization that in an imperfect world, being the one to break a cycle of conflict is often the most profitable long-term strategy for everybody involved. Okay, so let's zoom out for a second. What does all of this, the prisoner's dilemma, reciprocity, strategic forgiveness, what does it all tell us? Well, it's all building toward this profound conclusion, one that suggests we really need to update our fundamental understanding of evolution itself. You know, when we think of evolution, we usually think of two core principles we all learned in school. First, there's mutation, which is what randomly creates new traits and variations. And second, there's natural selection, which is what sorts through all that variation and picks the fittest traits. But Nowak argues that this picture just isn't complete. There is a third, equally powerful principle at play here. And that third principle? It's cooperation. It's not just some weird exception to the rule of competition. It is a fundamental engine of creation all on its own, a primary force that actually builds complexity in the universe. As Nowak puts it so perfectly, cooperation is the master architect of evolution. Think of it this way. Mutation and selection provide the bricks and the mortar, but it's cooperation that's the architect, arranging all those pieces into new and bigger and more complex structures. I mean, this is how life climbs the ladder of complexity, right? Genes cooperate to build chromosomes, cells cooperate to create organisms, individual animals cooperate to form societies. At every single major leap forward in the history of life, cooperation is the engine that's driving it. And that leaves us with this really powerful final thought. If cooperation is the creative force that built everything from the first living cell all the way up to our global civilization, what does that mean for our future? How can we better understand and actually apply these fundamental rules to solve our biggest collective problems, things like climate change or poverty? The answer, it seems, lies not just in outcompeting each other, but in figuring out how to become better super cooperators.